Hello students, so this is another lab work which is related to the multisim. So today we are going to construct a parallel circuit and we have to see that whether that parallel circuit obeys the Kirchoff's current law or not. Okay, so let us first go to the sources here, and in sources let me first have this DC power source. Let me put it over here. Similarly, now ground here as well, and let me put it here as well. Okay, so after it, let me have two resistors. So this is the first one and I have to put it here. Okay, similarly another one, and let me put it here as well, because I'm going to construct a parallel circuit which is going to have two branches. Okay, so now what we have to do, we have to construct a parallel circuit which is composed of a single voltage source and two resistors which will be connected in parallel with the voltage source. So what we have to do, I can also construct a circuit like that. I will be using the connections such like that these will be connected from here as well, but now in order to show it simply and for the simplicity, what I have to do, I have to rotate them. So in order to rotate them, I have to press Ctrl R here. So after pressing Ctrl R here, I can see that these will be rotated. Okay, similarly clicking over it and now again pressing Ctrl R, what will happen, these will be rotated here as well. Okay, so after it, let me connect the multimeter here. So the first multimeter here, second multimeter here, in order to observe the currents which are flowing through here. So again now rotating it, so Control R, clicking over it, and Control R here as well. Now this one, and double clicking over it, and let me have the 10 volts here as well. So it is up to you, whatever value you want it to be assigned. So clicking over OK and giving it some values, like this is, let me call it or let me call it 4 ohm. So this is a 4 ohm resistor. R2 is of 4 ohm as well. So from this circuit I can very clearly tell you that the current, the total current which will be flowing through this circuit will be 5 amps, because the two circuits which will be connected in parallel will give me, these are basically the same resistances. So the equivalent resistance here will be 2 ohm. So the current, total current here will be the I equal to V divided by the resistance, which is the equivalent resistance. So 10 divided by 2 will be the 5 amps. So in order to check the input current here, I am connecting this third multimeter here as well. Okay, so now in order to connect them here as well, so the connecting it with this one with this one, and also this one here with this one. Okay, now these are in series with each other here and here. Okay, here and here. Okay, so this is basically the parallel circuit which is composed of two resistors. Now in order to complete the circuit, what I have to do, I have to connect this ground connection here as well. Okay, so what I have to do, I have to run it, or I can also use this simulation switch as well. So let me run it from here, and for now running it, and I will see that it will have 5 amperes of current which is flowing through this circuit. Similarly, when the 5 ampere current will flow through these two same resistors, each and every one of the resistor here will be having the half of the 5 amperes. So that would be 2.5 amps. So double clicking over it, I will get that the current which is flowing through R1 is 2.5 amps. Similarly, the current through the XM1 is also 2.5 amperes. Okay, so that is the proof that in parallel circuits, what happens that current divides. Okay, so in order to check the voltage here in these resistors, what I have to do, let me stop it, and using this multimeter here for checking the voltage here, and I will see that the voltage here will be 10 volts. Okay, so now let me run it, and after running it I will see that the voltage across it is 10 volts. Similarly, in order to check it from, okay, so now let me first and now delete it, and now connecting it with this point, I will see that both of these are in parallel with each other. So in parallel voltage remains same. Running it, okay, and now pressing over it, I will see that the voltage across this resistor R1 is also 10 volts, R2 is also 10 volts, and this is also the source voltage where the two resistors are connected in parallel with it. Okay, so that's it for today, in which we have seen the characteristics of the parallel circuit, a very simple parallel circuit in which two resistors are connected in parallel with each other and with the source. So thank you so much, and I will see you with some more questions like this in our upcoming videos. Thank you.